All right, dealing with a video this time, dealing with how do we deal with angles in a similar way that you may have dealt with segments or some other things. It's kind of sort of the same process. We're going to take a look at categories for angles. These are things that you probably already know. We're going to look at naming revisited just real quick to make sure that you've got your notation-y type stuff down. We're going to look at interactions and the concept of bisectors, and then we're going to look at solving a couple of problems, although this is not killer. First of all, is the categories of angles. Angles can be classified according to a couple of different things. If you have an angle that goes from 0 degrees to 90 degrees, this is called an acute angle. If it is exactly equal to 90 degrees, this is a right angle. From 90 to 180. By the way, this doesn't include 90, doesn't include 180. This does not include 0, does not include 90. Has to be exactly here, but between 90 and 180 is called obtuse. And 180 degrees is called a straight angle. And 180 degrees or more is called a reflex angle. So those are your 5 categories, the way that we work with and deal with angles. So pretty simple, pretty straightforward. This is probably something that you already knew. All right, next thing I'm going to do is just want to revisit the naming that you should have seen in an earlier lesson. At the same time, I also want to do something that you didn't see in the same earlier lesson. The first one is angles can be named one of several ways. If this is A, B, C, it is legal to call this angle ABC, angle CBA, angle B, and angle 1. Those 4 names are all perfectly correct names for that particular angle. One of these 4 names gets thrown away as soon as I add on this ray and call this D. This angle that we began with can no longer be called angle B, because there's more than one angle at B, so I can't just name it by the vertex. Angle 1 is still okay, and these 2 angles are still okay for the original angle that I had there. Now, this is a tough concept for a lot of geometry students when they're first starting out, and that is these represent the object. It's the name of the object. Like your name is whatever your name is. My name is Steve Harris. It's the object. It's not a thing about me. It's the thing. It's me. Steve is me. When you go to measure the angle, say this angle turns out to be 38.9 degrees, that is not the name of the thing. It is an attribute of the thing. And so we change the notation just a little bit. If I want to talk about the measure of this angle, we say the measure of angle ABC is 38.9 degrees. Or the measure of angle 1 equals 38.9 degrees. This is an attribute of it, so it's a measurement, and that little m gets added on there. In the same way on segments, segment AB is the object. AB is the distance from A to B. Notice the difference in the notation, and it does matter. When we get into congruency and things like that later on down the road, the differences in the notation do matter, so get used to it. If you're talking about its measure, meaning an attribute of it, you would say it's the measure of. So for example, I'm Steve, I'm the object, but my height, 5'11" in a quarter or something like that, is a measurement of me, or 205 pounds is a measurement of me. It's not actually what I am. Okay, so that's an important thing. Students have a hard time with it. Make sure you talk to your teacher if you're having like, what are you talking about? I don't get it. That's fine. Just talk to your teacher. Outside there, that's as far as I'm going to go with it here in the video. Alright, so the next thing we want to take a look at is interactions and bisectors in the classifying thing. So the first thing is we have what's called adjacent angles. Adjacent angles are more or less angles that are next to each other. Okay, so adjacent angles would be this situation. Angle 1 and angle 2 are adjacent. They share the same vertex, and they share a side that makes them adjacent. If they don't share both of those attributes, for example, if I had this angle and then one splitting off like that, those are not adjacent angles. Right? Here's another one. Vertical angles are angles that are catty-corner to each other or across from each other, share the same vertex, share the same segments, but are on opposite sides from each other, these angles are always the same measure. They're always congruent. Congruent means things that are the exact same size and exact same shape. These would be definitely the exact same size. Angles have really only one kind of shape, a segment, and then a change in direction onto another segment. All right? So these are vertical angles. These are adjacent angles. And another interaction you can have is if you have two angles that add up to 90 degrees, we use the word complementary. If you have two angles that add up to 180 degrees, those are called supplementary angles. But it can only be two angles. Now, a lot of students assume that they have to be adjacent. They do not. So in this picture, I have two angles that add up to 180. These are 180 degrees. Sorry, these are supplementary because the line's 180. When you add these two together, you get 180. So these two angles shown here are supplementary. And they happen to be adjacent. But if I did the same thing and separated them, those can still be supplementary angles. Supplementary just simply means they add up to 180. They don't necessarily have to be attached to one another for that to be able to happen. All right? Last piece of the puzzle here is the concept of bisector, which was probably introduced in some other place. Bisector means to cut in half. So if I have an angle bisector is any set ray or line or segment or plane even for that matter that comes through and cuts an angle into two equal pieces. In order for it to be a bisector, this side and this side must be exactly the same measure. And last but not least, solving. Let's just use some common sense on this type of situation. If I say that this is 25 degrees, this is 91 degrees, then the measure of the big angle is 25 plus the 91, so that'd be 116 degrees there. That's just simply small angle plus small angle. 25 plus 91 is equal to 116. Doesn't matter if there's a variable there. If I still tell you this is 25, but instead this is 3x, and I tell you the whole thing's 116, then I know that 3x and 25 together must equal 116. Small plus small equals large. And then I can go through my process of being able to solve from there. Subtract 25 from both sides, and then divide both sides by 3. So this would be 3x is equal to 91. So x is equal to, 3 goes into 9 3 times 30 and 1/3. And not necessarily degrees. That's what x is. And again, then make sure you be able to answer the question. The last thing I can think of here that you may need to think through is if I have an angle and you're told this is a bisector and you're told this is 3x and this is 5x minus, say, 7. If this is a bisector, that means this angle equals that one. So you could do small plus small equals large. Or if you happen to have a bisector, you could say one side equals the other side. If I do a little subtracting, that's negative 2x is equal to negative 7. So x is 3.5. Is that the answer to the question? Maybe they want to know the measures of the angles. Maybe they want to know the measure of the big angle or whatever the case is. Those are some different types of problems that you may have to work your way through when dealing with angles. All right? So that's that. Until next time, see ya.